All right. So today we are going to be talking about chemical kinetics. So chemical kinetics is really all concerned about how fast reactions are occurring, or the rate at which they're occurring. So this is generally measured in a change in concentration of the reactants or products over a given period of time. The standard unit here is molarity per second. Whoops. So essentially, the rate of the reaction depends on the frequency of the collision between the atoms or molecules involved, because they have to collide in order to react. Collisions, they need to happen with both enough energy to cause the reaction, as well as the proper orientation of reactants. Things that can affect the rate of reaction. First, the physical state. So this really is all about the amount of surface area and how many atoms or molecules can come in contact with each other. So two solids, they're difficult to react because there's not a lot of surface area contact for them. However, two liquids, two gases, a liquid and a gas, even liquids and gases and some finely powdered solids, but two solids, not very easy to react. Another thing that can affect the reaction rate is the concentration, because if atoms and molecules need to collide to react, the more stuff that there is, the more likely there are to be collisions. The temperature has a lot to do with the rate of the reaction, because as you increase the temperature, things move faster, so that when they're moving faster, they're more likely to collide. And also, let's not forget that temperature is a measurement of the energy in a substance, and with higher energy, there are more molecules that have the required amount of energy that is needed, and so will be able to react. The final one are catalysts, and basically these help to align molecules so that proper collisions can occur. They are extremely important in living organisms. So we always talk about the rate of change when we talk about chemical kinetics. And we can talk about the rate of change in relation to one of two things: the rate at which reactants are used up or that they disappear, or the rate at which products are formed. We also tend to talk about the average rate of change, right, where average rate of change equals the change in concentration over the change in time, or delta concentration over delta T, or dx by dt for those who are into calculus. And here we're going to talk about instantaneous rate, because that is something that we tend to look at. And this is the rate at a particular instant in time. It is equal to the slope of the tangent line at time t on a graph of concentration versus time. Your book has a great visual for this, so you should check it out on page 568. But essentially, if you don't know how to do the calculus, you would graph and then draw a tangent line to a point in time, find the slope, and that will be your instantaneous rate. Okay, now there is stoichiometry involved in looking at chemical kinetics. So when we look at an actual reaction, the stoichiometry must be taken into consideration, because it will tell us the ratios of how fast products are forming and how fast reactants are being used. And so as a general equation here, if A plus B forms C and D, we have the rate being equal to, and you'll notice here this is negative, and there's no negative over here for C or D, because we are looking at the rate of the disappearance, or how fast the concentration of A is going down, or B, or for C and D, how fast the concentration is increasing or going up, right? So that's reflected in the negative and positive there. If we look at this in a case where we look at an actual reaction where we have hydrogen iodide reacting to form hydrogen and iodine, we have our rate is equal to either the disappearance of hydrogen iodide here, right, this term, or the formation of either hydrogen or iodine, because these should be occurring at the same rate. All right, so we can look at any of those, and it should give us the same rate. Now, how we write rate laws. We write them as the rate is equal to a constant times the concentrations of whatever is reacting raised to a power. And in this case, K is a rate constant. The letters in brackets are the concentration, and M and N are small whole numbers related, or small numbers, I guess they aren't always whole numbers, related to the reaction mechanism and reaction order, which we'll talk about soon, like right now. So reaction order, right? The exponents in a rate law are going to indicate the reaction order. And this gives us some information about how the rate is affected when concentrations are changed, and also the number of species involved. Now, if we are looking at our initial rate and using it to determine a reaction order, we will have done some experiments, in this case 3 experiments. We will have information about the concentrations of A and B that were used, and a measurement of our initial rate based on some experimental data. Now, if we look here, we can notice some things. Like when we double the concentration of B, nothing happens to the rate, right? Which means that the concentration of B has no effect on the rate. When we double the concentration of A, our rate does increase, right? Which is going to give us some information about that, right? So if we have our rate is equal to A to the M, B to the N, right? And we look at 2 of our rates here, all right? Rate 3 and rate 1, all right, being equal to 2 to the M, 1 to the N over 1 to the M, and 1 to the N, and 8 times 10 to the negative third over 2 times 10 to the negative third. All right, what we can do is we can simplify these expressions where we end up with, all right, all this stuff on the bottom is going to go away. This also going to go away. 1 raised to the power of anything is still 1. And we have 2 to the M is equal to basically 8 divided by 2, or 4. All right, and so when we look at this, right, hopefully we can all solve this, that 2 raised to the M equals 4, so M is going to equal 2, right? So this is a second order rate, right? Because it is raised to the second power, and so it is a second order reaction, or second order rate. Okay, So that is it for this video. We're going to talk more about reaction orders and chemical kinetics in the next video. I just didn't want to make this one too long, so I'll see you in the next video.